Good morning. Welcome to the AMES development program featuring Crane software and MOV analysis. Today I want to talk about switch contacts, their positions during the stroke, and how you look at that, how you relay what you see on a trace to what you see on an electrical schematic. I have a few pages open here, so you're going to bear with me as I scroll through them. This first page shows a valve in the open position and it's being driven closed. Okay. This next window shows the open switches. Shows a 12.5 volt makeup and then a 5 volt makeup. And here we see a 5 volt, this is a closed switch, you see a 5 volt trip, 10 volt trip, and a 2.5 volt trip. And in the bottom window I show you motor inrush current, running current, and it goes up a little bit at the end here for seating current. Alright? Okay, the next window I have up for you is a couple of electrical schematics. This first one I have here, let's look about what switches we have here. We have O for open coil, C for closed coil, and R and a G for red and green lights. In this case, kind of just name these things. They're not there's no standard at any plant that I would rely on. I would always look at a print, but you're looking for something that looks like this. It may look drastically different, but if you look in all the prints that'll be buried, they'll show a little switch with a bypass switch around it. And in this case, the open circuit has an open torque switch, an open torque switch bypass, and an open limit switch. Okay. Closed control circuit has a closed torque switch and a closed torque switch bypass. The bypass switch, as you can see here, bypasses the torque switch, and its purpose is to allow either the motor to start and get moving before and then the switch will drop out, or in the open direction, it's usually the bypass switch is in the circuit until after all the opening events of a dynamic condition are over. So anywhere from 20% up to 50%, depending on what plant you go to. Closed bypass, there's a lot of control schemes out there now. Initially it was usually set on rotor 1, so it went out the same time that the open limit made up, but now it's on its own rotor, and it can be set independently wherever it is in the stroke. Alright, and then you got the red and green lights. Now what position do you think this valve is in right now? Looking at these switches, we have a green light made up, red light out, closed torque switch open, closed torque switch bypass open, open torque switch closed, open torque switch bypass closed, and open limit switch closed. Have we figured it out? Okay. Let's go look at the trace real quick. Just remember all that. Okay. So we're looking for the red light out. Red light out goes here. Okay. Also, the torque switch is open, so red light and torque switch were open, and the torque switch bypass was open, and all the other switches were made up. The green light and open, and the open torque switch and or control switch, whatever it is, and open torque switch bypass are all made up. So that valve must be closed. Okay. So you can tell the valve position just by looking at the indication you have. When you walk up to the limit torque and you see the switches in this configuration, you have a good heads up that the valve is probably closed. Okay. Conversely, let's look at open. Alright, I'm just going to go quickly back and forth. Closed, open, closed, open, closed, open. Okay, did you notice which switches changed? The green light is out, The red light is on. Closed torque switch bypass and closed torque switch are made up. On the open control circuit, we have the open torque switch bypass open and the open limit open. Okay, this valve is in the open position. Let's go back to the trace. On the trace, I have the closed side on right now, but we can look at it over here. The valve is full open here, right? Okay, so if we look here, all the open switches are open and all the closed switches are made up, as you can tell by the 0 volts and the 17.5 volts. All those switches are made up. Alright? The UDS/VIPER software has several advantages over the quick look, as you can tell stroke where the valve is in its stroke and whether things are working properly without having the motor energized. That's the downside to coil currents. But while we're talking about coil currents, let me bring one up here so you can see it. Okay, I brought up closed coil currents. Now this is how we'd be performing analysis in votes or quick look mode. A lot of plants don't have these switch leads, but you can see the bypass rolls and the current gets bigger here. Remember, it's just two parallel paths. When one parallel path drops out, more current's going through the switch that remains, and that's why you see more current. Alright, how does that sound? Next thing I want to show you is mid-stroke. Again, so we have closed, open, mid-stroke. Now, if I was a smart man, I'd move those like I just did. So I'd have open, mid-stroke, closed, open, mid-stroke, closed. Now, my last one I'm going to show you is open stroke stopped. It's showing valve in mid-stroke with the two lights on. The closed circuit is still can be energized, and here we have the open circuit. The open torque switch bypass is open, but so is the torque switch. So this valve stopped on torque switch. Again, you'd be able to see this if you went up to the limit torque, if you were troubleshooting, and you saw the open limit made up and the open torque switch open. There's definitely a problem here, right? It could be the limits have drifted a bit and it's hitting the back seat and it stopped it, or there's a mechanical binding somewhere in the valve stroke. All right, so that's enough about contacts and their positions and what it looks like on a valve stroke. Please stay tuned for more videos from the AMES development program.